In this video, I'm going to work with a same question but label the mass of the block as M1, M2, and M3. So it's going to be a more general case, and I think it will be more helpful for you guys. This is the problem we are solving. We have a stack of blocks on a slippery surface, so these dashed lines indicate that there's no friction on this table. And the one on the top has mass M1, the bottom one has M2. M2 is pulled by a string through a pulley, and under this is a mass M3. So let's draw out the force acting on each block. I'm going to use red color to indicate which block I'm working on. Let's work on M1 first. So first, because this system is on Earth, so I'm going to have a gravity pulling the block M1 downward. This is on M1 by the Earth, because the Earth is the one giving gravity to this block. Then because the block is touching M2, M2 is going to give some force on M1. Let's first focus on the vertical one, because there is a surface under M1 which can give M1 some force. So even though M1 is pulled by gravity, it's not going to fall down. And this vertical force is going to be called a normal force, because the direction is normal to the surface that they are in contact with. It is a force on M1, and it is exerted by M2. The M2 block will also give another force on M1 block, which is the friction. Because there is friction and they are not sliding against each other, there must be a horizontal force acting on M1 to pull it to the right. That makes it move along with M2. So let's use this horizontal force to represent the friction again. It is acting on M1 by M2, and it is a friction. So these three forces are the forces acting on M1. Now let's look at M2. For M2, it is in contact with table, M1, and also the string. These will all give forces to this block. And also the gravity is acting on M2. So let's first write there's gravity. Well, this one is the one acting on M2. And we have a normal force from the table, which is pointing upward. And it is a normal force because it's normal to the surface, and it is acting on M2 by the table. Now, M1 on top will also push down on this block, so it will also give a normal force. Let's use the dark color for this one, because the normal force from M1 on M2 will be a pair with this one on M1 by M2. So the table will give a normal force, which I draw in a darker green by table, and M1 will give a normal force onto M2. This is F normal force, but this normal force is acting on M2 by M1. Now, because there's friction between M1 and M2, so M1 is going to kind of drag M2 back when M2 was pulled by the string. The direction of this friction is then going to be pointed toward the left, which is opposite to what M1 is getting. So we will have a friction force, and this friction is acting on M2 by M1. We see they are both friction, but they are different because we are looking at the force acting on different objects. One is M1, another one is M2. Finally, we have the tension force. This tension force is going to be acting on M2 at this point, connected by the string, and it will be a force acting on M2 by the string. This concludes all the force acting on M2. Now let's work on the simplest case, which is M3, because it's not touching table, it's just touching the string. The string will pull up, and give M3 a force. This is again a tension force, but this one is acting on M3 by the string. So you see these two tension force are both tension force, but they are different because we are looking at different force. One is the tension force acting on M3, another one is acting on M2. Then there's gravity pulling this M3 down. So we have F gravity on M3 and by Earth. So these are all the forces acting on three different blocks separately.